intlx Solutions, founded by engineers, valued for our expertise. Hey everyone, welcome back. If you caught our last video, we walked through the complete process of deploying KVM onto an Avaya S8300E server, and today we're going to be diving into part 2. Now that our KVM host is up and running, I'm going to show you exactly how to spin up and deploy your very first virtual machine on top of it. We'll cover the configuration step by step to make sure everything runs smoothly. Let's jump right into it. To kick things off, we'll get right into our KVM host. Our first order of business is to create a dedicated staging directory. This gives us a clean workspace to start staging and working with our OVA and QCOW images. I'm going to run through these setup commands briefly just on the screen, but if you want to dig into the documentation behind them, you can find the exact details in the official Avaya guide deploying Avaya Communication Manager in a virtualized environment, release 10.2, March 2026 edition. Next up, we need to get the image files over to our server. I've already grabbed the Avaya Communication Manager Simplex KVM OVA from the Avaya support portal, so now we just need to upload it straight into that staging directory we just created. Just a quick heads up here, this transfer is going to take some time. Keep in mind that we're pushing this onto an S8300E, which relies on a single 7200 RPM spinning disk drive, so don't be surprised if it feels a little sluggish. Grab a coffee, let it do its thing, and we'll be right back when it finishes. Alright, I've sped up that transfer significantly for the video. The real time over my Wi-Fi connection pushing that fairly large file to this spinning disk took closer to 20 minutes. Now that it's finally done, we'll log back into our KVM host and navigate straight into our staging directory. From here, we need to extract the OVA image, and as you can see on screen, unpacking this file gives us exactly what we need, including the two primary QCOW2 image files for our operating system. Now, one thing to note here is that these QCOW2 images, they come thinly provisioned out of the box, and that's almost certainly done to save some serious time and bandwidth during the download and upload process. However, for our deployment, we need them thick provisioned, and to do that, we're going to run these specific commands to convert both the system and VAR disk images to thick provisioned. Let's punch these in and get them converted. And if you're using copy-paste like I'm doing here, I recommend editing the commands in a text editor to avoid any unwanted spaces or carriage returns from being introduced into the command. Before we move any further, it is highly recommended to verify your disk image sizes to ensure that they perfectly match what's expected in the documentation. Now pay close attention here. I'm running the standard ls command first to show you a common pitfall. If you look at this output, the file size listed here won't actually match what the system reads later. To get a true story, we need to use the qemu-img. I think that stands for qemu-imaging. I'm not even sure if I'm pronouncing that right, with the info subcommand instead. And as you can see right here, that gives us an accurate reading. We're looking for exactly 14 gigabytes for the system disk and 50 gigabytes for the VAR disk. With our images verified, the next step is to move both of these disk image files over to their final directory. Because these files are so big, transferring them will take a substantial amount of time. In my case, it actually took roughly 45 minutes. This is because we're shifting a total of 64 gigabytes of data from one location to another, all on a single spinning magnetic platter. Alright, now that the files were successfully moved, we'll navigate straight into their new directory. From here, we will need to run these next commands to properly update the ownership and permissions of our QCOW2 disk image files so that the hypervisor can access them. Once those permissions are set, our final housekeeping step is to completely clean our staging directory. We'll go ahead and wipe out all of these temporary files we were working with earlier so we aren't wasting any of that precious disk space. With our environment completely prepped, we are finally ready to spin up our virtual machine. Now that our backend disk, image, storage, and permissions are dialed in, it is time to actually build our virtual machine. To do that, we're going to log into the KVM Cockpit by opening up a web browser and navigating to port 9090. If this is your very first time logging into the Cockpit interface, there's one quick thing you need to do. Make sure that at the top of the screen here that you toggle administrative access on just like this. Without that elevated access, you won't be able to build your virtual machine. In fact, if you don't enable administrative access, you won't even be able to see any of the virtual machines built on your KVM's host. With admin access enabled, we're ready to add our first virtual machine. On the left-hand menu, navigate to System, select Virtual Machines, and then click on Import VM. In the dialog box that pops up, we need to fill in a few key configuration details. First, give your virtual machine a name, and then point it to the exact location of your system disk image file. Next, for the operating system dropdown, you want to select Red Hat Enterprise Linux 8 Unknown. Finally, go ahead and populate the memory field. Just make sure that you match the exact specs outlined in the Avaya documentation for your specific virtual machine instance. Lastly, choose Import and Edit. We are nearly done configuring our virtual machine. There are just a few remaining steps to lock down. First, we need to modify our existing system disk. Under the Disks section, select Edit on your current system disk. From here, change the bus type to SCSI and switch the cache mode to Direct Sync. Next, we need to attach our second storage volume. Click on Add Disk to bring up the configuration window. From the source, choose Custom Path and enter the exact file location of our var disk image. Just like the first drive, set the cache to Direct Sync and the bus to SCSI. Once those are dialed in, simply click Add. Navigate back over to the Overview section of our virtual machine and change the firmware from BIOS to UEFI. Edit the CPU value to conform to the value specified in Avaya documentation for your specific virtual machine instance, as shown here. Lastly, we'll scroll all the way down to the network interfaces. Now, we won't actually be using out-of-band management for this particular virtual instance. However, I am going to go ahead and add a second interface anyway, as shown here. There are two good reasons for doing this. First, it gives us the flexibility to spin up out-of-band management options down the road if requirements change. And secondly, and more importantly, it prevents any potential errors with the back-end deployment scripts which may be explicitly looking for that secondary interface to be present. With that network interface attached, our virtual machine configuration is officially complete, and we're ready to power on our virtual machine for the first time. To spin up our virtual machine, we'll navigate back to the top of the VM page and click Run. One feature I absolutely love here is how easily you can view the console directly from this main page. From this point on, configuring the virtual machine is exactly what you're already used to seeing. You'll use the standard craft logins for the initial deployment and enter the familiar first-time network configuration parameters on first boot. Once that initial setup wraps up, you'll be prompted letting you know that the virtual machine needs to be rebooted. Let's go ahead and take care of that right now. We'll log directly into the system management interface of our Communication Manager. Navigate over to Server Maintenance, and by selecting Shutdown Server and checking Restart After Shutdown, we will trigger a clean reboot. Now we can jump right back over to our KVM Cockpit, and the cool thing is we can watch the entire reboot process happen live from our console. And after a few minutes, the cycle completes, and let's see if we can access our web interface once again. Yep, we sure can. Everything looks great. And that completely wraps up this deployment. I really hope you all found this breakdown helpful, and I want to thank you all for watching, and I look forward to learning with you all again in the next video. intlx Solutions. Empowering people, connecting businesses.